where mean, median, and mode are same. So having one peak, curve having only one peak make a symmetrical distribution. If a curve doesn't make a symmetrical distribution, that means the right tail is longer or left tail is longer. So we can say that the positively skewed or negatively skewed distribution. So testing of skewness, the first point is that means arithmetic mean, median, and mode are equal. So we can say that there is no skewness in the distribution. That means the distribution is symmetrical. So just so for the second point, uh, second point we write as if arithmetic mean is less than the value of mode, less than the value of mode. So the tail would be on left or right side. That means the distribution, that is the distribution is negatively or positively skewed. Negatively or positively skewed. Third point, the quartiles are equidistant from median, then there would be no skewness. There would be no skewness. Now we move to the main part, that is how to measure the skewness. So method of measuring the skewness. Method of, we write as methods of measuring the skewness. Method of measuring the skewness. Basically, we calculate the relative measure of skewness. The relative measure of skewness, relative measure of skewness are called the coefficient, are called the coefficient of skewness, are called the coefficient of skewness. So we used methods for calculating coefficient of skewness. Coefficient of skewness. So the methods used to calculate used for calculating skewness. Calculating skewness. Method 1. Method 1 is Karl Pearson coefficient of skewness. Second method, Bowley's coefficient of skewness. Bowley's method. Third one is Kelly's method. Simply you can write in the form of method. Kelly's coefficient of skewness, Kelly's method. And fourth, we use method of moments. So with the help of moments, we calculate the skewness also. That means beta 1, beta 2, gamma 1, gamma 2. So we use all the coefficients. So before calculating beta 1, beta 2, we have to understand moments, central moments, moment about origin, moment about at any value, at any point. So then we will discuss. So we start with the first method. So first method is Karl Pearson coefficient of skewness. So we start with method 1. Karl Pearson's coefficient of skewness. Karl Pearson coefficient of skewness. So for calculating Karl Pearson coefficient of skewness, it is easy. That means we already covered mean, median, and mode and standard deviation. So for calculating this, that means we require to calculate mean, median, mode, and standard deviation. So first method, that means calculate coefficient of skewness, we denote it as SK, coefficient of skewness. So this is equal to mean minus mode upon standard deviation. So you can write as mean, we denote it as x bar, minus we denote it mode mo, or we write in this form mode, or upon sigma. So mean minus mode upon standard deviation. This is used where mode is not ill defined. And for second method, the mode is ill defined, so we use second formula. So that means we write as 3 mean minus median upon standard deviation sigma. So this is second method. So we use only two methods for calculating Karl Pearson coefficient of skewness. So on the basis of these two, how to interpret the value of skewness as so absolute skewness interpretation if skewness provide us a provide us zero value, so we can say that a distribution is symmetrical. A distribution is symmetrical. So that means zero value means there is no skewness, and if you provide a provide positive value, so we can say that positively skewed distribution. Positively skewed distribution. Positively skewed distribution. And third one, provide a negative value. Provide a negative value means negatively skewed distribution. Negatively skewed distribution. So when after solving the problem, we have to check that means the value lie in which, that means negative value, positive value, or zero value. And remember this, the skewness lies between -1 to +1. -1 to +1. When you solve the problem, so the value lie between -1 to +1. That means all right. Otherwise, your calculation is wrong. You have to check the calculation in each case. Each case means for the case of Karl-Pearson coefficient of skewness, case of Bowley's coefficient of skewness, case of Kelly's coefficient of skewness. In each case, the value should lie between -1 to +1. Okay. So obviously we have solved the problems related to mean, median, mode, and standard deviation. Similar problem we take for calculating the skewness. So we take one problem related to skewness. Then after we will discuss next method. So we start note one problem. Note down the problem. From the following data, calculate the Karl-Pearson's coefficient of skewness. Coefficient of skewness. Marks given in this form: 6, 7, 8, 9, 10, 11, 12, and corresponding frequency. Frequency is given as 3, 6, 9, 13, 8, 5, and 4. So we have to calculate skewness, coefficient of skewness. So for solving this, that means we have to require, that means solving the mean, solving mode, and standard deviation. So basically we talk about the standard deviation. That means this is a discrete series. So there are three methods for solving discrete series. One is actual mean, second is assumed mean, third is step aviation method. So we can solve any one of them method. So we solve this problem by using assumed mean method. So we solve this problem by assumed mean method. So solve this problem by assumed mean method. So we write marks, first column marks taken as x, six, 7, 8, 9, 10, 11 and 12. Second we write a frequency. Frequency is 3, 6, 9, 13, 8, 5 and 4. Third, we use the assumed mean. So we see that the number of values are 7. So we consider the middle value as a mean, or you can consider any one of them. So we consider here 9. So this 9 as assumed mean. So let assumed mean A is equal to 9. So we consider assumed mean A is equal to 9. So now we calculate the deviation. So deviation D is equal to x minus A. So we write as x minus 9. Deviation D, x minus 9. So this is minus 3, minus 2, minus 1, 0, 1, 2 and 3. There are 7 values. And we calculate next FD. We calculate FD. So FD means 3 3 is 9, 6 2 is 12, 9 1 is 9, 0, 8, and 5 2 is 10, or 4 3 is 12. FD, and next we calculate FD square. FD square. D square means 3 3 is 9, 9 3 is 27, and 2 2 is 4, 4 6 is 24, 1 1 is 1, 1 9 is 9, 0, 1 1 is 1, 1 8 is 8, 2 2 is 4, 4 5 is 20, 3 3 is 9, 9 4 is 36. So we do the summation of f. The summation of f is 6 3 9 9 18 18 13 31 31 or 39, 39 or 5 44, 44 or 4 48. And the summation of FD, we do the summation of FD 9 12 21 9 30 0. Very good. And the summation of FD square, calculate. $124. Very good. 124. Now we start with mean. So first we calculate the mean. While calculating the mean, so we have the formula a plus summation of FD upon summation of f. This is the formula for assumed mean method. So summation of FD upon summation of f. So A, we take assumed mean A is 9 plus summation of FD is 0, 0 upon summation of f is 48. So this equal to 9 plus 0 is equal to 9. So our mean is equal to 9. So here mean is 9. Now we calculate the mode. So that means when you use the first formula, so we need to calculate the mode. So for mode, we know that any value which have the highest frequency is known as the mode. So we see the question or this one. So highest frequency is Rohit, Ragni. What is the mode of this problem? 13. Very good. So highest frequency is 13. So in front of 13, the value is 9. So mode is 9. Yeah, very good. So mode is 9. So mode is equal to 9. Having highest frequency. Yeah, symmetrical distribution, very good. So on the basis of numerator, you can say that that means mean minus mode upon standard deviation. The mean minus mode, that means numerator is 0, 0 upon something equal to 0. That means the distribution is symmetrical. There no skewness in the distribution is symmetrical. Okay, when you calculate standard deviation, so then you in one step you can calculate the standard deviation also. So we have the formula for calculating standard deviation: summation of fd square upon summation of f minus summation of fd upon summation of f to the whole square. So this equal to summation of fd square, which is 124 upon 48 minus 0 upon 48 to the whole square. So calculate this. What is the value? 1.60. 60. So that means you can take 2 decimal place to 1.61. Yeah, 606 or 3 up to 3 decimal you can write 6067. Yeah. So coefficient of skewness Sk is equal to mean minus mode upon SD. So this equal to 9 minus 9 upon 1.606 equal to 0. So interpretation we already written above. So if value is 0, so that means no skewness. So we can say that the distribution is symmetrical. The distribution is symmetrical. Okay. So hope you understand the problem. That means simply we calculate mean, median, and standard deviation. Mean, mode, and standard deviation, or on the basis of that we can. Next problem. Calculate Karl Pearson coefficient of skewness of the data arcs given as 0 to 10, 10 to 20, 20 to 30, 30 to 40, 40 to 50, 50 to 60, corresponding number of students, that is frequency, 10, 20, 30, 50, 40, and 30. So this is the continuous series problem, but formula remains same as discrete. Just we find out the midpoint in this case. So you can write first column as marks, second column as midpoint, third column as number of students means frequency. And this problem we solve by using step deviation method. So we see that 0 to 10, 10 to 20, 20 to 30, 30 to 40, 40 to 50, and 50 to 60, 50 to 60. So this is 10, 20, 30, 50, 40, and 30. Sorry, frequency. 10, 20, 30, 50, 40, and 30. Midpoint 5, 15, 25, 35, 45, and 55. So having same interval, that means 10. So we can solve by using step deviation method. So to solve by step deviation method. Step deviation. So step deviation method we also require assumed mean. So we can consider assumed mean is 30, 30, 40. You can choose any one of them. So here we 45. So choosing assumed mean as 45. So A equal to 45. So we calculate the deviation. Deviation D. We solve by step deviation method. So we write deviation as x minus A upon C. So x minus A upon C, C is the interval. So here C is equal to 10. So interval is 10, C or I, we can write in form of C or I, noisy. So this equal to, so x minus 45 upon 10. X minus 45 upon 10. So x means 5, 5 minus 45, minus 40 upon 10, minus 4. So for simplifying the calculation, basically we use this method. For 15 minus 45, 30, 30 upon 10 minus 3, 20 minus 1, and 35 minus 45, 25, this is 2. This is minus 1 and 0 and plus 1. Okay. Now we calculate FD. We calculate FD. So F into D, minus 40, minus 60, minus 60, minus 50, 0, and 30. And corresponding we calculate FD square. FD square. So for calculating FD square, D square means 4 4 is 16, 16 into 10, 160, 3 3 is 9, 9 into 20, 180, 2 2 is 4, 4 3 is 12, 120, and 1 1 5 50, 0, 30. So we do the calculation, the summation of f, sum of the frequencies, sum of fd, and sum of fd square. What is the value of this? 180, Ravini, very good. 180. Second, Devangini, minus 180. And third one, 540, very good. Okay, very good. So this is 540. Now first we calculate the mean. So for calculating the mean, mean for deviation, what is the formula? So mean is equal to A plus summation of FD upon summation of F into interval. So multiply by the interval. So we assumed mean is 45, 45 plus summation of FD. This is minus 180. minus 180 upon summation of f is also 180 into interval. Interval is 10. So what is the mean? Calculate this. 35. Very good. So mean is 35, and we calculate the mode. So for calculating the mode, uh, we see that the highest frequency is 50. So this is the highest frequency. Yeah. So we calculate mode. So this is f1. Previous value is f0. This is the f2, and corresponding the median class is L1, L2. This. So okay, Nitesh, very good. So we calculate the mode. Mode equal to L1 plus f1 minus f0 upon twice f1 minus f0 minus f2 into L2 minus L1. So this equal to 30, 30 plus f1 is 50, 50 minus 30 upon 52 is 100, 100 minus 40 minus 30 or into 10. What is the value? Calculate this. The mean. Okay, very good. Arshita, Apur, you also respond the same. Okay, 36.67. So this is 36.67. So the mean is this one, and this is mode, and calculate a standard deviation also. So here we require to calculate standard deviation also, because mean and mode are different. So standard deviation, we have the formula summation of fd square upon summation of f minus summation of fd upon summation of f to the whole square into interval c. So this equal to summation of fd square. Summation of fd square, what is the value of summation of fd square? 540? 540, very good. So this is 540 upon 180 minus 180 upon 180 to the whole square into 10, interval 10. So 540 upon 180, this is 3. So 3 minus 180 upon 180, 1. So minus 1 ka square is 1. So 3 minus 1 into 10. So this is a root 2. Root 2 into 10. So value of root 2 is 1.414 into 10. So this is 14.14. Yeah, standard deviation is 14.14. Now we calculate skewness. Yes. So skewness is equal to mean. We calculate mean minus mode 36.67 upon standard deviation 14.14, negatively skewed obviously. So what is the value? Okay, 32.40. Yeah, Isika, very good. So this is minus 0.118. So means negative. Give the negative value. So we can say that negatively skewed. Devangini, in negatively skewed distribution, right tail is longer or left tail is longer? Right in chat box. Devangini, Ankit, if our distribution is negatively skewed, the right tail is longer or left tail is longer? Okay, very good. So this is first method for calculating skewness. We have to check the skewness of the distribution. Yes, very good. Now, second method, which is Bowley's coefficient of skewness. So second method